Right, my name is Jose Alcerreca. I'm a developer relations engineer at Google. And today we're going to talk about data binding again. I was here last year and I gave a talk called Modern Data Binding. And it had an introduction to, there you go. Sorry about the cursor. It had an introduction to the library. But the feedback we got from it was that a lot of people are using already data binding, they're familiar with it, so they wanted something more advanced, so here we are. So I'm assuming that if you're here in an advanced data binding talk, you are familiar with layout expressions, provided, and custom binding adapters and observability. So if you're watching a video at home and you're not familiar with the library, you should probably switch to the modern data binding talk. If you're here and you're not familiar with the library, then I guess you're stuck. Sorry. Well, you're not stuck. You can always switch the channel to another. But don't do it because I see you, all right? Cool. So I'm going to talk about a lot of stuff. This talk is advanced. It doesn't mean that it's hard to understand or that I'm going to talk about things that are hard to implement. It's just that there are topics that you don't normally get in an introduction to the library. So let's talk about binding adapters first. And the reason why I have to address this issue is because if you go to any internet forum, Reddit, of course, there's always that person saying, oh, but data binding is about having code in the XML. Luckily, in 2019, there's always someone else replying to that comment saying, well, if you have a lot of logic in your XML, you're doing it wrong. So how much is too much code in an XML? Who thinks that this layout expression could be improved? Yeah, like 20%? All right. What you can do here is move to a binding adapter to make your layout expression or your layout much more readable. So we can define something like that. Hide if minor, and then we pass the H here. As a reminder, a binding adapter looks something like this, and this is how we create custom attributes. You have a binding adapter annotation with the attribute, then you have a static method that receives the view and the value of that attribute. So you release your app internationally, and you realize that the age of majority is different in some countries or some regions. So we need to have the country in our binding adapter somehow, right? So this is the second feature of binding adapters. You can have multiple parameters in them. So we do something like this. We pass the H to hide if minor, and we pass the country to country, and in our binding adapter, we add both attributes and we receive the values in the method. So the only thing missing would be the actual implementation. So we do something like this. We check the H against a static map of ages of majority that we have somewhere in our app. But this is not great, is it? First, we don't need to pass two parameters to the binding adapter. We can just pass the user object. So just because you can doesn't mean that you should use all the features in data binding. The target here is to make the layout our layouts readable. And we can actually do better than this. Let's not use binding adapters at all. Let's reuse one of the binding adapters that I'm sure we all use, something like gun unless, and pre-compute the isAdult property somewhere in our data layer, because it makes no sense to do this, this small computation, this small comparison on the main thread. Also, it reads very well, gun unless the user is adult, right? Even better, this property should be computed in the server so that we only maintain one list of countries, right? So the target here is that you have to always keep your layout simple. Data binding is not about showing off how much we know about the library. It's about making our layouts very simple and very readable. So speaking of binding adapters, let's quickly address this feature, which is about using all and new parameters. So the feature is pretty cool. If you duplicate the number of parameters that the method in a binding adapter receives, then you get the old value first and the new value second. So when is this useful? It's very useful when you're dealing with listeners. So as a reminder, when you have a lambda expression, binding adapter is going to try to match that expression to a binding adapter that has a listener. And the way it matches it is if the lambda expression has a view as a receiver, it receives a view, then data binding is going to look for a binding adapter that has a listener, and that listener can be an interface that has a method that receives a view. In our second example, it receives a view and a Boolean. It's going to look for a method that receives a view and a Boolean. So that's how the listeners are matched. OK, so back to old and new. The problem that we're trying to solve is here. Let's say you want to create a binding adapter for on-layout change. The way you add, or the way you set layout change listeners to a view, you don't set them, you add them. So there's a list somewhere. So a binding adapter can be potentially called multiple times. You kind of don't really know how many times a binding adapter is going to be called. So what we do to prevent adding a listener too many times is we use this technique. We get the old value, the old listener, and the new value in the binding adapter. And then the first thing we do is we check for null. If the old listener is null, it means it's the first time we call the binding adapter. If it's not null, then we remove it before adding it again. And you'll see that this pattern is everywhere in the provided binding adapters. It's also useful to avoid unnecessary work. So in this example by Chris Baines, he posted an article on this. He uses this feature to avoid unnecessary work. So he's checking that previous lines is different from new lines, so that the new value is actually different from the previous value to do some work. This makes a lot of sense because you don't want to be setting that click listener unnecessarily. You can read more about this in the Android developers publication over at Medium. The article is called Lessons Learned. And speaking about binding adapters, let's talk about how to create them in Kotlin. So the data binding library is going to look for static methods all around your app. So you can define a function as a top level in a Kotlin file to generate a static method. This is one way of doing it. Another way is by putting the binding adapters inside an object. It has to be an object, or it can be a companion object in a class. But you have to remember to add the JVM static annotation. If you don't add it, you're going to have a very bad time debugging what's wrong with your binding adapter. Don't ask me how I know it, but this is a pattern that I don't recommend. What the cool kids do nowadays is this. Use an extension function on the class that you want the binding adapter applied on. The cool thing about this, and I think this is a coincidence, how Kotlin compiles this is it creates a static method, and it puts the instance of the view as the first parameter, which is exactly what data binding looks for. And the cool thing about this pattern is that the list of attributes matches the list of values that we receive in the method. So it's a very nice one-to-one relationship. So there's actually a fourth way of creating data binding adapters, and they are actually dynamic binding adapters. And this is where you use the data binding component, probably known for bad things more than good things. But this is how you use data binding component in the binding library. So instead of putting your binding adapter in an object, we can put it in a class. And we can actually make that class receive things like fragments, which are only available during runtime, right? So we can just add binding adapters there. And we can actually use things like fragments inside the binding adapter. So if you compile this project, the library is going to find this class that contains a binding adapter, and it's going to generate this interface called the data binding component. For each class that has a binding adapter, it's going to generate a getter. So you just have to implement this interface in another class. So we call it fragment data binding component. It also receives a fragment. And the only thing we have to do is override the getter and return an instance of the class that we just created. So now we have two classes, but we haven't really specified what fragment to use or where to use it, right? We do that during inflation, or a little bit before inflation. So we create this fragment data binding component. We pass this because we are in the fragment. And then we pass this data binding component to the inflate method, or we set the default component in data binding util. If you do this, then you will have access to the fragment inside a binding adapter. So this is cool, but the API is a little bit limited. This should be used as a last resort, really. It's much better if you try to keep your binding adapters in a static context. The cool thing about this is that if you get the first class and you make it abstract, you can actually use different versions of it depending on your app configuration. So you can put one version in one flavor and another one in another one, or you can use Dagger to replace it whenever you want. So that's the whole point of the data binding component. If you want to read more about this particular use of data binding component, you can go to the GitHub browser sample that we have in the Android architecture components repo. So now let's talk about two-way data binding. Now for something completely different. What is two-way data binding? In here, I have two checkboxes. The first one has a layout expression assigned to the checked attribute so that we can make changes to the UI from a view model. And then we use onCheckChange to receive user actions, right? So whenever the user checks this checkbox, we are going to receive it in the remember me changed method in the view model. So is this two-way data binding? Well, no, it's just one-way data binding, two ways, so in different directions, and twice. Two-way data binding is what you see in the second checkbox. So the checked attribute in a checkbox has two-way data binding functionality enabled. So you can use an expression like this. A two-way data binding expression is very similar to one-way, but it has an equal sign between after the at symbol. So what do we put on the other side? What is this view model.rememberMe? Well, you can put a mutable live data, for example, so that from your view model, you set a value every time you want to write or change the UI. And also, you can use transformations to receive the user actions. But if you want more flexibility, you can use the observable. You can use an observable class. So in this case, I have here an observable view model. This is a class that we use in some examples. So if you Google it, you'll basically find it. And the way you create a property is by adding the bindable annotation to the getter of the property. So the property in this case is called remember me. In the getter, you can do whatever you want. You can compute the value, or you can return a backing property like I'm doing here. And then in the setter, we receive a new value. In this case, it's a Boolean because we're talking about a checkbox and the checked attribute of a checkbox. The first thing you have to do is avoid infinite loops. So you break the infinite loop here so that, because in two-way data binding, we have the problem that if you don't break the infinite loop here, the setter is going to basically call the getter, and then it goes through the UI, it goes to the setter, getter, etc. So it goes on forever. All right. So if the value is new, we can save it into the backing property. And then the important thing is that you call notify property changed. So as you can see here, we're passing the remember me property here. So what the binding library does, it gets the name from the getter. It transforms it to underscores from camel case, and it generates the property. And with this notify property changed, what we're telling data binding is that the getter should be refreshed. The value of that property should be refreshed, so that all the layout expressions that are related to this property need to be reevaluated. So that's exactly what's going to happen. Notify property change at some point is going to call the getter, and the UI is going to be refreshed. After that, or before that, you can save data, you can save to share preferences, or send it over the internet, or whatever you need to do from the view model. So what if you want to implement your own two-way data binding functionality? What if you have a color picker, and you want this functionality in the color attribute? Well, it's actually a little bit convoluted, so it would take me like 10 minutes to explain it in detail. So I'm just going to leave you the 3 steps that you have to take. First, you create the binding adapter that sets the UI attribute, so that's the normal binding adapter that you would use. But second, you have to create a binding adapter that has an inverse binding listener. So what you do in this binding adapter is you listen for changes so that when the attribute changes, you can tell data binding that something changed. So you call this listener. And after that, you create a special inverse binding adapter that reads the value from the view. It actually gets the value and gives it to data binding. If you want a full example of this, go to the Android data binding repo that we have in Google Samples. It has a basic sample and a two-way data binding sample. The two-way data binding sample has a huge README with a lot of information. So if you go to the complex two-way case, it explains exactly what I just described in detail in this case. Next topic. So we released data binding with a collection of classes called observable fields. And then 2 years later, we released live data with architecture components, and they're both observable classes. So live data was lifecycle aware. Not that this matters, but we made it compatible with the data binding library. It also has some other advantages, like it supports transformations, so you can make some fields or some live data depend on other live data. And it also has support, or other libraries have support for live data, like Work Manager or Room. So, I mean, there's really no reason not to migrate from observable fields to live data, or not to use live data, really. If you're using observable fields, you can still use them, of course. And this migration is super easy. It only requires 2 steps. The first one, converting the actual observable field to live data. If you use observable fields in your layout, you just change observable field of something to live data of something. That's very, very simple. In your view model, it's a little bit more complicated. If you're exposing an observable field from a view model, then this is actually a good thing. The recommended pattern is that you use a mutable live data inside your view model that is private to the view model, so it's only mutable by the view model, and then you only expose the immutable version of it. This is another advantage that live data has over observable fields. There's no immutable version of observable field. Step number 2 is you have to call set lifecycle owner on the binding object. So whenever you or however you obtain the binding, after that, you call lifecycle owner and you assign it, you call set lifecycle owner, really. If you're in an activity, you pass this, that's fine. But if you're in a fragment, you have to pass view lifecycle owner, because the lifecycle owner of the view of the fragment is different from the one of the fragment, because fragments are hard. So if you want to read more about this particular migration, I just posted an article on Android developers I posted an article on the Android developers publication over at Medium. And this is my favorite topic. It's about testing binding classes. Can we test? The question is, can we test data binding expressions? And the answer is, sure you can. Just start an emulator, fire up an activity, and use a UI testing framework to navigate around until you get some coverage of those expressions. But this is a bit slow, right? Can we actually unit test data binding expressions? This would be the interesting part. And the answer is, yeah, kinda. We can unit test data binding expressions. It would be still an instrumented test, so we need an emulator or a device. But we wouldn't need an activity. We wouldn't need Espresso to navigate around. Let me show you how it's done. I'm going to show you here an example. This is a form with an email, a password, edit texts. It has a checkbox with the typical, I've read the terms of service. You know, the checkbox you check after reading the terms of service. We all do that, right? And it has a button, and this button is only enabled if the checkbox is checked. So how do we implement this feature? Do we read here? Do we read from the view model, from a property in the view model, and then we add a listener to the checkbox that talks to the view model, and then the view model? Or we can just do this. This is a very nice feature of data binding. You can use attributes in other views, and you can refer to those views by their ID. So just by doing this, we have the full functionality of the UI implemented. The thing is, how do we test this? How do we unit test this? We don't even have a view model to test here. So we're going to create a test class. We're going to run it with the Android JUnit forerunner. And the test is going to run on the UI thread, so we add that annotation. And the interesting thing is that we inflate the binding inside the test. So this is our subject under test. This is what we are going to be testing against. The first thing you have to do on the binding is execute pending bindings. This method brings the binding to a ready state. So it evaluates all the layout expressions, and it sets all the appropriate values on the variables and on the bindings. After that, then if you want, you can make assertions, although this is not the assertion that we are looking for. This is just making sure that the sign up button is initially disabled. And then we can make changes. So we change the attribute of the read TOS view. We set it to true, or the checked attribute, we set it to true. After this, we can, again, call binding execute pending bindings to reevaluate that layout expression. And now we can assert that the sign-up button is now enabled. So that's it. It's pretty cool. Turns out that we can unit test data binding expressions. It's not a pure unit test, of course. I mean, we're using an emulator. But it's pretty low in the testing pyramid, I would say. It's like 10 times faster than a normal UI test. So definitely something to think about. So in this section, I want to explain a very special use case. There's a trend nowadays that makes you expose the state of your screen as a single object, as a single observable, right? So instead of doing this, which is what you would normally do, you expose different observables from your view model. So you have a name, you have a number of followers, etc. Whenever something small changes, like the number of followers, you don't want to refresh the whole UI, right? And data binding helps you doing this. If you change the number of followers, only a subset of the layout expressions are going to be reevaluated. So only a subset of the UI calls and the binding adapters are going to be used. And that's good. However, if we follow this pattern where you only have one UI state object, it doesn't matter what changes. All the UI calls are going to be all the UI calls are going to be made again. So you are going to refresh the whole screen, which can be fine. I mean, it's not the end of the world, but it's not ideal. So what can we do about this? So instead of having or binding the view model state directly to the layout, we can do something like this. Maybe we can map it to 4 different variables. And in the fragment, we observe this, observable that is exposed from the view model, and we map each of the buckets of state to a variable. What's happening here? The expressions are reevaluated when you bind an object to a layout variable. So in practice, you're refreshing the whole UI. So you're back at square one. What you can do is, because we are exposing our live data, we can use live data in the layout and do mapping between those. So we get the view model state, and we map it. We just filter the piece of state that we're interested in, and we use this, this function on live data called distinct until change. This is going to make sure that only an update is emitted when the value is new. Distinct until changed is in alpha. It's part of the Lifecycle live data artifact, but it's a very, very small piece of code. So if you're not comfortable using alphas in your app, then maybe you can just copy the code over, but don't tell anyone I said that. So the final feature I want to talk about is includes. It's so super powerful in data binding. Let's say you want to create this screen. It has 2 player layouts, and you don't want to repeat yourself, so you create an include. right? You create a user profile layout. But how do we do this with data binding? How do we convert it to data binding? So it's super simple. We can create a variable called users, or we could have user 1 and user 2 in the parent layout. But in this case, it's a pair of user. And then we assign users first and users second to the user attribute of the include. So what is this attribute? Is this coming from a binding adapter? Can you actually add binding adapters on include? That makes no sense. User here is actually a variable of the child layout, which is super powerful because with absolutely no code, we are controlling here with data binding 3 different layouts. So finally, I wanted to talk about Android Studio. We have stats for data binding, and they say that the usage of the library is going up, not just in absolute numbers, but also in percentage of production apps using the library. So this actually justifies things like having a dedicated team working on data binding for Studio, which is amazing. The problem is that data binding and Studio are tightly coupled. So improvements made now might not land until 3.4 or 3.3, or 3.5, sorry. So here's a list of some of the things that we are fixing in 3.4, some of them, but most of them in 3.5. Typing latency has been fixed. Some cryptic errors have been rewritten, finally, because there were some that were really, really hard to understand. Auto-completion has been improved. We have new lint checks. Some XML tags are automatically closed now. Refactoring has been improved a lot. Finally, we get code folding for the less than symbol. This doesn't mean that now data binding supports using the less than symbol directly in XML. We're still XML compliant. It just means that Android Studio is going to show the symbol instead of the ampersand thing. And my favorite is that errors now show up in the build output toolbar. So instead of having to go through a huge list of statements to find your data binding error, now it's finally in the build output toolbar. It even has its own data binding compiler category. And it even has a window showing the actual error. And this is absolutely amazing, for me at least. So try Android Studio 3.5 if you want to see all of these features. And report bugs, please. So some links for you. We have the official documentation that we change regularly. So if you haven't been around there, make sure to check it out. The code lab is probably too basic for you, but it's a good thing to pass around to your colleagues if you want to sell the library at work, for example. We also use data binding in a lot of samples. So we have the official Android data binding repo. We use it in Android architecture components, in some branches in Android architecture. We use it in the Google I/O app and the Android Dev Summit app as production apps, also in Plaid from Nick Butcher, and in TV from Chris Baines. So if you have any questions, I'll be around in the conference, so feel free to stop me and talk to me. Thank you very much.